Namaste everyone. In this video we shall answer this question. This question was asked in 2023 CBSE Science Board Examination question paper. There are 3 sub questions here. So in the first sub question he says we need to determine the speed of light in diamond if the refractive index of diamond with respect to vacuum is 2.42. Speed of light in vacuum is 3 into 10 power 8 meter per second. So first let us concentrate on solving the first sub question, wherein we need to determine the speed of light in diamond. So let's first write down what's given in this question. So they have given us the value of refractive index of diamond with respect to vacuum. Refractive index of any medium with respect to vacuum is called as absolute refractive index. So it is generally represented by the letter N, and N is equal to C by V. N is equal to C by V is the formula to calculate refractive index or absolute refractive index of a medium, where C is speed of light in vacuum, V is the speed of light in the given medium. Here the given medium is diamond, so I'll write ND, D for diamond. Similarly V, I'll write it as VD. VD represents the speed of light in diamond, and we need to find out the value of VD here. They have given us the value of refractive index of diamond or absolute refractive index of diamond as 2.42. Refractive index of any medium with respect to vacuum is called as absolute refractive index or simply refractive index. Now substituting these values here, and they have also given the value of C, which is 3 into 10 power 8 meter per second. C is generally used to represent the speed of light in vacuum. In case if this value is not mentioned, it is better we remember. So speed of light in vacuum or approximate speed of light in air is 3 into 10 power 8 meter per second. Now let us substitute these known values in this formula. ND is equal to C by VD. So ND value is 2.42, C value is 3 into 10 power 8 meter per second, and we need to find out what is the value of VD. So I can rewrite this as VD is equal to 3 into 10 power 8 divided by 2.42. So this one I would like to simplify it like this: 3 by 2.42 into 10 power 8. I will keep this 10 power 8 undisturbed till I get the final answer. So here I can multiply numerator and denominator by 100 so that I can get rid of the decimal point in the denominator. So this becomes 300 divided by 242. When I multiply numerator and denominator by 100, this 10 power 8 will remain as it is. Now let's first cancel this 300 and 242 by 2. So this becomes 150 by 121 into 10 power 8. So let's divide 150 by 121 and check what will be the answer. So 150 divided by 121, 121 ones are 121, so the difference will be 9. This is 29. Now 29 is less than 121, so I'll take a decimal point there, so it becomes 290. Obviously 121 into 2, if you multiply 121 by 2, we'll get 242. So let's simplify this. So you will get it as, means if you subtract 242 from 290, this will be 8 and this will be 4. So I can take a 0 here. So by what number should I multiply? So if you multiply by 4, so we'll get 484, which is more than 480. So I'll multiply by 3. So 121 into 3, 363, it will be 363. Now if you subtract, this will be 7 and this will be 1 and this also will be 1. Now we can take a 0 here, so obviously we'll try by 9. So 121 into 9, so 9, 18, 1, this will be 1089. So this process continues like this, and it will be non-terminating, repeating decimal expansion here in the place of quotient. So 1.239 can be rounded off as 1.24, can be rounded off as 1.24. So the value of Vd is 1.24 into 10 power 8 meter per second. So what is the question? In the first sub question, we need to find out the speed of light in diamond. Now we can say the speed of light in diamond. Speed of light in diamond is 1.24 into 10 power 8 meter per second. So we have answered the first sub question. Now let's see what is the second sub question and how to solve it. Here they say refractive indices of glass, water and carbon disulfide are 1.5, 1.33 and 1.62 respectively. So we need to arrange the angle of refraction in the increasing order in these media. So what are the three different media here? Glass, water and carbon disulfide, and they have given the refractive indexes of these three media. So let's see how to solve this second sub question. So they have given us the refractive index of glass. So refractive index of glass means absolute refractive index of glass, that is Ng, that is 1.5. refractive index of water, I'll write it as Nw, it is 1.33. refractive index of carbon disulfide, so I'll write it as Nc, C for carbon disulfide, and it is 1.62. Now we need to find out what is the angle of refraction, or in fact we have to tell or write the increasing order of angle of refraction in these media. So let's take the first media, glass. Now they have not mentioned the other media or the medium in which incident ray is present. So let's assume the medium in which the incident ray is present as air. Now let's draw the normal. Normal is an imaginary line that is perpendicular to the interface or the boundary of the two media. Here the two media are air and glass. In the question it says the ray of light is incident in these media at the same angle, and he asks us to assume that angle as theta. So the angle of incidence is theta here. So we know the angle of incidence is the angle between the normal and the incident ray. Now whenever a ray of light passes from rarer medium to denser medium, so here air is rarer medium, glass is denser medium. Rarer medium is a medium in which speed of light is less, denser medium is a medium in which speed of light is more. Now whenever a ray of light passes from rarer medium to denser medium, it will bend towards the normal. Now let's take the other two media. So before that let's mark this as the angle of refraction. So I will write it as Rg. Rg here represents angle of refraction in the glass medium, and angle of refraction is the angle between the normal and the refracted ray. So Rg here represents angle of refraction in the glass medium. Now let's take the other two media. Now first let's consider water. Again let us assume that the incident ray is present in air. as mentioned in the question, the angle of incidence for all these three media remains same, and it is theta. Again, here this particular ray of light is traveling from rarer medium to denser medium. Water is denser medium compared to air. Air is rarer medium compared to water. It will bend towards normal. Again, the ray of light will bend towards normal. And this one, let's call it as RW. So RW here is the angle of refraction in the water medium. What is the last medium? The last medium is carbon disulfide. Carbon disulfide. So let's again draw the normal here. This is the incident ray. As per the question, the angle of incidence should remain same in all the three media, so I'm assuming it as theta. The medium here is air. The medium here is air. So this particular ray of light is traveling from air to carbon disulfide, that is a rarer medium to denser medium. So this particular ray of light will again bend towards normal, and let's call this angle as RC. That is angle of refraction in carbon disulfide. Now we need to arrange these three angles of refraction in the three media in the increasing order from smaller to bigger. For that, we need to compare these values of RG, RW and RC. Now this comparison can be done in two ways. In the first way, as you can see, carbon disulfide is having the highest refractive index, then glass, then water. So if the refractive index of a medium is more, then the light will bend more. If the light bends more towards the normal, then this angle will be less. The more the light bend towards the normal, less will be the angle of refraction. So light will bend the highest in carbon disulfide among these three media, as it has the highest refractive index. So for while comparing the angles of refraction in these three media, let's write like this. So NC is greater than NG is greater than NW. So as I mentioned, so greater the refractive index, the more the light will bend towards the normal, the closer the refracted ray will be towards the normal, and consequently the angle of refraction will be smaller. So I have to write like this: RC is less than RG is less than RW. This is the increasing order of angle of refraction in the three given media. So this is the answer to the second sub question. So what is another way of doing this? I said there are two ways of writing this increasing order. So what is another way? So we are still in second sub question, wherein we need to arrange the angle of refraction in the increasing order. We have already arranged the angles of refraction in the increasing order in the three media by using one method. Now we shall use another method, and that method we need to, or we can use Snell's law of refraction. This is the second law of refraction. The mathematical form of Snell's law of refraction is given as n21 is equal to sin I by sin r. Refractive index of second medium with respect to first medium. Here if you see, the first medium is air. The second medium, if you take glass, second medium will be glass. If you take uh, water as another medium other than air, then water will be the second medium. Now from this I can write sine r is equal to sine I by n21. Now this sine I will be constant for all the three medium. Why? Because the value of I is constant in all the three media, that is angle of incidence is same for all the three media. Now sine r will depend on the value of n21. How does it depend? Sine r is inversely proportional to the value of refractive index. Inversely proportional to the value of refractive index means if refractive index is highest, then sine r will be less. If sine r is less, then r also will be less. We know that for sine theta will increase as theta increases. We have learned this in mathematics. So here, how is sine r dependent on refractive index? It is inversely proportional. And rewriting this, nc is greater than ng is greater than nw. So we can write sine r is less than sine rc is less than sine rg is less than sine rw. From this again I can write rc is less than rg is less than rw. In this way also we can determine the increasing order of angle of refraction in the three media. Angle of refraction in the three media. Okay. Now the third sub question. So we've answered the second sub question. We have decided the answer by using two different ways. So in exam you can use any of the ways, whichever way you feel comfortable, whichever way you feel as easier, you can use it. Okay, now let's concentrate on the third sub question. In the third sub question they have given the speed of light in glass, that is Vg is given. So what is Vg here? Vg represents speed of light in glass, and they have given the value of Vw, that is speed of light in water, as 2.25 into 10 power 8 meter per second. Which one of the two is optically denser and why? So which one of the two means which one of the water or glass is optically denser. So optical density of a medium is inversely proportional to speed of light in the medium. That means if speed of light is less, then that medium will have more optical density, or we can say that particular medium is optically denser. Now comparing the speed of light in glass and water, we can see that speed of light in glass is less compared to speed of light in water. So we can say glass is optically denser than water, because the speed of light in glass is less than speed of light in water. By giving these reasons, we can conclude that glass is optically denser than water. So which one of the two media is optically denser? It is glass. And why means you can give these reasons to support your answer. Now let's concentrate on this question B. There is a ray of light that is incident normally at the water glass interface. It enters a thick glass container filled with water. What will happen to the path of ray after entering the glass? Give reason. So here they're talking about two media, that is water and glass. Now this is the interface between the two media, water and glass. So water glass interface. It's here the very important word is normally. So the ray of light is incident normally. Now first let us draw a normal. Now when a ray of light is incident normally, it means that the ray of light is coincident with the normal, or the incident ray is coincident with the normal. So whenever a ray of light is incident normally, it goes straight, it does not bend. Its speed will change, but its direction will not change in the second medium. So in this case, the second medium is glass. Whenever a ray of light is incident normally, that time the direction of light in the second media, in this case glass, will not change. So what is the answer? What will happen to the path of ray of light after entering glass? Give reason, he says. So the path of a ray of light, remains unaffected. This is applicable only when the ray of light is incident normally. Give reason. How do you give reason for this? Is again going back to what we have learned, that is refractive index of second medium with respect to first medium, that is sin I by sin R. Here the second medium is glass, first medium is water, so NGW. Second medium is glass, first medium is water, so NGW will be equal to sin I. What is I? Now we know I represents angle of incidence, and angle of incidence is the angle between the normal and the incident ray. Because the incident ray is coincident with the normal, angle of incidence will be 0 divided by sin R. Now refractive index of glass with respect to water cannot be 0. Anyways, cross multiplying, sin R is equal to sin 0 degrees. Sin 0 degrees we know is 0 by NGW. So NGW cannot be 0. So 0 by non-zero number will become 0. Sin R is 0 implies that R is equal to 0 degrees. That means angle of incidence, if angle of incidence is 0, angle of refraction also will be 0. Here R represents angle of refraction. So if angle of refraction is 0 means what? The refracted ray and the normal are coincident with each other. So the refracted ray will also be along the normal. That's why we can say that the path of the ray of light remains unaffected when it is incident normally. We have answered all the sub questions of the given question. Thank you for watching. Please subscribe, like and share. Thank you again.